Hi, welcome. A warm welcome to you. In this video, we will see factorization of polynomials with the help of algebraic identities. As you are aware, algebraic identities are algebraic equations which are true for all the values of variables given to them. So, let us try to solve some problems which are given using algebraic identities. So the problems will be in one of the forms given here. We have to identify in which form the problem will fit into. Then we have to apply that formula and have to factorize the polynomial. So let's start. Let's take some simple examples. So let's start with this example. 4y square minus 4y plus 1. We have to factorize this. You can see that it's having 3 terms. So let us see what are the formulas where we have 3 terms. So here I have 3 terms and here I have 3 terms and also the first 3 fit into. But I see that I have a middle term negative, so I'll prefer to go with this. So let us see also here, if you look at the first term here, you see a square here, 2 square is 4 and y square. So can I go ahead and write this as 2y whole square? So now my formula is a square minus 2 into a x is nothing but equal to 2y into, we see that x equal to 2y whole square minus 2 into 2y. I'm not left with anything else other than 1, and also it fits in exactly that this is equal to 1 square. Now this is in the form of x y square, x square minus 2xy plus y square. So you can directly write it as 2y minus 1 whole square. Let's do another problem. I think you're okay with that. So let us see here. I have to simplify this. 18a square minus 50. I look at the formulas whatever I have. I see that there is only one where I have 2 terms. Remaining all have 3 terms or more than that. So I'll be using this formula. But I see that I should have square here. That means I should have 1 square, 2 square, 3 square, 4 square, but I see 18. So what I will do first is I'll try to simplify this. I see that 2 9s are 18, 2 25s are 50. So I'll take 2 common out and make it as 9a square minus 25. Why we did this? We did that because we should have, to be in the formula of x square minus y square, I should have a perfect square here. I don't have a perfect square now. Now this is in the form of x square minus y square. So I can go ahead and write it as 9 is nothing but 3 square, 3a whole square minus 5 whole square. We know the formula for x square minus y square, that is x plus y into x minus y. So I can write x plus y, that is 3a plus 5 into x minus y, that is nothing but equal to 3a minus 5. Let's do another one. Let's look at this one. It says 3p square minus 24p plus 36. So this should fit into one of the forms of, if you look at here, it should fit into either the first or second. That is what I see, because it's in squares, no cubes there, so no cube formula will be applicable. It is not having three terms, it is not very big, so this also will not be applicable. Nothing of this sort. It should be coming from 1, 2, 3. And it's not 4 because there are no two terms, there are three terms. And I see that it is not a perfect square. So let us try to take out common anything I can factor out. I see that 3 I can take common. 3 into 8 is 24, 3 into 12 is 36. So I can go ahead and say 3 into p square minus 3 into 8, so 8p plus 12. Now if I look at this, I have here something like x square, that is fine, perfect. But 12 is not a perfect square, so the formula of x minus y whole square will not fit into. So I should go for the x plus a into x plus b formula, which is nothing but factorization of. It's not for perfect square, but you are trying to factor them out. So now you can use splitting the middle terms approach, and you can see that sum equal to minus 8 and product equal to 12. So I need two numbers such that sum equal to minus 8 and product equal to 12. P square. I know that whenever the product is positive, I should have the same sign there. So 12, 1 12s are 12, 2 6s are 12. So I will say minus 2p minus 6p plus 12. That is nothing but equal to 3 into, I can take p common here. It leaves me p into p square minus 2 minus 2p. I can take 6 common here, so that this is again p minus 2. So this is nothing but equal to 3 into p minus 2 into p minus 6. Let's look at another one. This is straightforward, given to us in the form of a plus b plus c whole square, so we can straight away go ahead and simplify that. Let's apply that formula. It's not visible here, but you remember that x square plus y square plus z square plus 2xy, 2yz, 2zx. They go in one particular format, so it's very easy to remember, right? Let's go ahead and do this. This is minus 2a whole square x square plus y square, that is 5b whole square, plus z square, that is minus 3c whole square, plus 2 into minus 2a, that is x, into y, that is 5b, plus 2 into y 5b into minus 3c, that is z, plus 2 into z minus 3 into x minus 2a. So this is your x square plus y, x plus y plus z whole square. This is in the form of x plus y plus z whole square. So x equal to 2a, y equal to 5b, and z is equal to 3c. So let's try to simplify this. Minus square is plus, 2 square is 4, so I can say 4a square plus 5 square is 25, 25b square plus minus 3 whole square is 9, 9c square plus 2 into 5 10, 10 into 2 is 20, and there is a negative symbol there. So this becomes minus 20 ab. This becomes minus 20 ab. 2 5s are 10, 10 into minus 3 is minus 30. So this is minus 30 BC. This is 2 3s are 6, 6 2s are 12. and minus into minus is plus, so this becomes 12CA. That is how you can do that. Let's look at this one. I have here so many a square, b square, c square. So something looks like a plus b plus c whole square formula, like this formula. Now let us see how we can solve this. Now the first term should be perfect square. Yes, it is. 3 square is 9, 2 square is 4, 4c 16. Now the only problem here is I see some negatives, so I should be able to identify which term is negative out of A, B, C. Okay, so let's put down the formula first. What is the formula for this? The formula is x square y square z square 2xy 2yz 2zx. We see here x square is fine, y square is fine, z square is fine, because I can write all of them as squares. So my x is 3a. Let's put down them one after other. Okay, let us say my x equal to 3a. Okay, y equal to 2 square, so I will say 2b. Okay, and z equal to 4c. Okay, that is also is fine. But I see some positive terms, some negative terms, right? So for that, what we should do is we should compare the terms. See here 2xy. xy is positive, that means both of them is positive. Now you know x and y are positive. Let us go to the next one. And we see 2yz is negative. We already know y is positive, so z should be negative. Another way of approaching this is check which is a common term in the negative terms. The negative term is 2yz here, 2zx here. Which is common term? Z is common term. So z is negative. Z should be minus 4c. So minus 4c. Let's expand this and see. This is nothing but 3a whole square plus 2b whole square plus minus 4c whole square plus 2 into 3a into 2b plus 2 into 2b into minus 4c plus 2 into minus 4c into 3a. Now only the point we have to remember is whenever some are positive terms or some are negative terms in 2xy, 2yz, 2zx, look for the common terms. If xy is positive, that means both x and y are positive. If yz is negative and zx is negative, which is common is z. So I know if I check this, it's exactly fitting with, I have simplified. So now I know this is nothing but equal to 3a plus 2b minus 4c whole square. That's nothing but equal to 3a plus 2b minus 4c into 3a plus 2b minus 4c. We'll do some more examples in the next video. We'll continue this. Thanks for visiting. Bye for now. See you in the next video.